To determine the appropriate wire size for a 500-foot run to a 40-amp subpanel, we need to consider voltage drop. The maximum allowable voltage drop for a subpanel is typically 5%. We'll calculate the required conductor size to stay within this limit. The circuit impedance, represented by Z, consists of the resistance, R, of the conductors, and the inductive reactance, XL, resulting from the alternating current. For this particular scenario, we'll assume the inductive reactance is negligible. Formula for voltage drop is voltage drop equals current times impedance, or V equals I times Z. Now, we need to determine the conductor resistance. Conductor resistance is calculated using the formula R equals ρ times L divided by A, where ρ represents the resistivity of copper, which is 10.37 micro-ohm cm. L represents the length of the conductors, which is 500 feet for both the outgoing and return runs, totaling 1,000 feet. A represents the cross-sectional area of the conductors, which is what we need to find. Combining the previous steps, we get voltage drop equals current times ρ times L divided by A. Substituting the values, we have 0.5 times 120 volts equals 40 amps times 10.37 times 10 to the power of -6 ohm cm times 1000 feet divided by A. Solving for A, we find that A equals 10.28 times 10 to the power of -6 cm squared. Looking at standard conductor sizes, the closest standard conductor size to 10.28 times 10 to the power of -6 cm squared is number 8 AWG. Therefore, to minimize voltage drop to 5%, you should use number 8 AWG copper conductors for the 500-foot run to the 40-amp subpanel.